So generative AI is projected to add up to $4.4 trillion to the global economy every single year.
Yeah, that is trillion with a T.
Trillion with a T. It is massive. But, here's the dirty secret of the current AI boom that no one really talks about,
Oh, I think I know where you're going with this.
right? Almost nobody actually wants to build the infrastructure required to run it. It's like electricity in the 1800s.
That is a really good way to look at it.
Yeah, like everyone desperately wants a light bulb in their business, but absolutely no one wants to build the power plant. Laying the high voltage lines, managing the grid, all just to keep that single bulb glowing.
Because building that power plant is chaotic. I mean, it requires highly specialized talent that is nearly impossible to hire right now.
Exactly.
The hardware supply chains are constantly bottlenecked. And honestly, the capital investment alone would sink most companies before they even flip the switch.
And that tension right there, that is exactly what we are unpacking today. Welcome to this deep dive. Today, we are looking at the invisible machinery that is actually powering this massive AI revolution for you.
Right. The stuff behind the curtain.
Exactly. Our mission today is to cut through all the heavy tech jargon to understand exactly how organizations are building AI behind the scenes. More specifically, we're exploring why Amazon Web Services AWS is aggressively maneuvering to become that ultimate power grid.
Creating a one-stop shop, essentially.
Yeah, a place where companies can just plug in their appliances and get to work.
It really is a profound shift in how the tech industry operates right now. If you walk into any boardroom today, the conversation is no longer about whether a company should adopt AI.
Right. That debate is over.
Completely over. Ended a year ago. The only question now is how. How do you implement it securely? How do you scale it across thousands of employees? And crucially, how do you do it without your cloud infrastructure costs spiraling completely out of control?
Let's start right there, actually, with the sheer scale of this.
Yeah.
Because there is a statistic from Gartner that honestly made me stop and scratch my head when we were prepping for this.
The adoption rate one.
Yes. They are predicting that by 2027, over 80% of enterprises will have generative AI applications actually running in production.
Yeah, that's a huge jump.
It's massive. For context for you listening, in 2023, that number was less than 5%. I really have to push back on this.
Go for it.
Going from under 5% to over 80% in roughly 4 years seems, I don't know, entirely disconnected from reality.
Well, I mean, it sounds impossible on its face, yes.
Right, because to build these complex models, you need massive data sets. You need wild amounts of computing power. You need data scientists who command like $500,000 salaries.
Not easily. Sometimes more.
Exactly. So if you're a mid-sized retail chain or a regional hospital network, how on earth are you supposed to clear those hurdles and roll out a production-level AI application by 2027? You can't just snap your fingers and suddenly own a supercomputer.
You can't. And that is exactly why that 80% adoption rate is only feasible because of a massive pivot toward fully managed services.
Okay, what does that mean in practice?
It means that mid-sized retail chain isn't going to buy their own server racks. They aren't going out into the open market trying to outbid tech giants for GPUs.
Right, because they'd lose.
They lose instantly. Instead, they are offloading the entire infrastructure nightmare onto cloud providers like AWS.
So they aren't building the power plant. They're just paying a monthly utility bill.
Precisely. AWS is looking at these massive roadblocks, data management, security, sheer compute costs, and they are building the underlying scaffolding.
So the enterprise just focuses on the business side.
Right. AWS takes on the heavy lifting of the hardware and the network architecture, so the enterprise can focus entirely on the actual business application. If every company had to build this from scratch, honestly, we'd be lucky to hit 10% adoption in a decade.
Okay, well, that makes the timeline make a lot more sense. So let's look at how AWS is actually executing this, starting with developers who do want to get their hands dirty.
The builders.
Yeah, the teams that actually want to build their own custom machine learning models from the ground up. AWS's foundational solution for this is Amazon SageMaker.
Right.
And reading through what SageMaker actually does, the best analogy that comes to mind is it's like a fully stocked, ultra high-end commercial kitchen.
Ah, I like that. Let's break that down. How does SageMaker function as the kitchen?
Well, think about a brilliant chef, or in this case, a highly paid data scientist.
Yeah.
Historically, a data scientist spent 80% of their time doing what is essentially carpentry.
Wiring things together, yeah.
Exactly. They were setting up servers, trying to get databases to talk to each other, dealing with plumbing and wiring. But if you're a chef, You don't want to build the oven before you cook.
No, you want to cook.
Right. You just want to bring your recipe, your data, into a pristine kitchen and start cooking. SageMaker seemed to provide the entire kitchen setup so the developer can just focus on the food.
That is a highly accurate way to frame it because it highlights a massive inefficiency in how human labor has been utilized in tech.
How so?
Well, you have these brilliant mathematicians and data scientists wasting weeks just configuring network storage. It's a huge waste of money and talent. SageMaker automates the entire machine learning lifecycle.
So it takes away the busy work.
Exactly. It handles the initial data preparation, the feature engineering, and the actual model training.
Right. And the toolkit they provide inside this kitchen is incredibly deep. Like, there's a feature called SageMaker Autopilot, which brings in AutoML capabilities.
Right, which is huge for efficiency.
But they also throw around a lot of heavy terminology in the sources, like hyperparameter optimization. If we stick with our kitchen analogy, what exactly is a hyperparameter and why does it need optimizing?
That's a great question. So in machine learning, a hyperparameter is basically a master setting that controls how the AI learns.
Okay, so not the data itself.
Right, it's not the data, it's the rule for how to process the data. So going back to your commercial kitchen, imagine you have a highly advanced oven.
Okay, I'm with you.
Hyperparameter optimization is like the oven automatically testing hundreds of different combinations of temperature, humidity, and fan speed on tiny pieces of dough until it finds the absolute perfect setting to bake your specific loaf of bread.
Oh, wow. So it just runs through all the options.
Exactly. Doing that manually takes weeks of trial and error. SageMaker just automates it.
Wow. Okay, so it's an oven that figures out how to bake the food perfectly on its own. And importantly, it seems like AWS isn't forcing developers to learn a whole new set of tools to use this kitchen.
No, not at all.
Because they integrate natively with popular frameworks like TensorFlow, PyTorch, Hugging Face.
Exactly. To push the analogy one step further, TensorFlow and PyTorch are basically the standard pots, pans, and knives that data scientists are already trained to use.
So they don't have to relearn how to chop onions.
Right. AWS doesn't force them to throw away their favorite tools. They just provide the ultimate environment to use them in.
And the craziest part of all of this is the speed. By automating all the setup and testing, teams are taking development cycles that used to take months and shrinking them down to weeks.
It's revolutionary for speed to market.
But it doesn't just stop when the model is built, right? There is a huge emphasis on MLOps machine learning operations.
Yes, MLOps is the unsung hero here. Building a model is just a science experiment. Running it in the real world is a business.
That makes sense.
MLOps is like the restaurant's expediter, standing at the kitchen window, ensuring that the 1,000th dish that goes out tastes exactly the same as the first one.
So it's about consistency.
Exactly. It monitors the AI for drift, meaning if the real-world data starts changing over time, MLOps alerts the developers that the model needs to be updated. It ensures the environment remains stable, reliable, and repeatable.
Okay, but cooking from scratch still takes time, even in a world-class kitchen. What if an enterprise is on a massive time crunch?
Like they need a solution yesterday.
Yeah. Say you're a massive logistics company and you need to deploy an AI to summarize your shipping contracts by next Friday. You can't wait weeks to train a custom model. You need a pre-trained world-class brain right now. How does AWS solve that urgency?
That urgency is exactly why AWS built Amazon Bedrock. If SageMaker is your commercial kitchen for building from scratch, Bedrock is catering from a Michelin star restaurant.
Okay, I like that.
It is designed to accelerate generative AI without forcing you to build or train a large language model yourself.
Right, because Bedrock provides API access to what they call foundation models.
Wow.
And looking at the list, it's basically a who's who of the smartest AI models on the planet.
It really is an impressive lineup.
You can access Anthropic's Claude, Meta's Llama, models from AI21 Labs, Stability AI, and even Amazon's own in-house models called Nova.
Yeah, Nova is their newest addition.
Right. And you could use these for anything, right? Building chatbots, summarizing dense legal documents, writing code, searching enterprise databases. But wait, hold on. This is where I really have to push back, because there's a massive red flag here regarding privacy.
Let's hear it.
Well, if you are a major bank or an insurance provider, you are sitting on highly sensitive, heavily regulated customer data, financial histories, medical records.
The crown jewels of the company, you know.
Exactly. So if Bedrock relies on API access, meaning my bank's data is being piped out to Anthropic's Claude or Meta's Llama, isn't that an inherent security vulnerability?
I see where you're going.
How on earth can a bank trust that Meta isn't going to learn from their proprietary customer data and regurgitate it to a random teenager using a public chatbot next week?
You've just articulated the single biggest roadblock to corporate AI adoption over the last 2 years. That exact fear of data leakage has kept CIOs up at night.
I mean, I'd be terrified.
Rightfully so. But this is the genius of how AWS architected Bedrock. It is essentially a one-way mirror.
Okay, explain how that works.
When you use Bedrock to access Claude, you are not sending your data out into the public version of Anthropic's brain.
Oh, you aren't?
No. Instead, AWS essentially takes a private, isolated copy of that foundation model and places it securely inside your company's existing AWS environment, inside your virtual private cloud.
So it lives in my house.
Exactly. Your data never leaves your secure perimeter. More importantly, AWS has ironclad contractual guarantees that your customer data is never used to train those underlying foundation models.
Okay, wait. So Claude can read my internal banking documents,
Yeah.
summarize them, give me incredible insights. But the second that interaction is over, Claude completely forgets everything it just read.
Has no memory of it.
It doesn't take my data back to Anthropic headquarters.
Exactly. The intelligence comes to your data. Your data does not go to the intelligence. And that solves the ultimate enterprise dilemma. Companies can finally leverage the absolute smartest AI models in the world without triggering a massive compliance nightmare or risking their intellectual property.
That structural isolation makes total sense. Okay, so Bedrock gives a company this incredible, secure brain. But businesses don't just need a brain in a jar, right?
No, they need it to actually do work.
Exactly. They need the AI to actually see, read, and interact with specific workflows. They need specialized skills.
Right. You need the AI to perform targeted actions.
Which brings us to AWS's specialized AI services. I like to think of this as a team of hyper-specialized AI interns.
That's a fun way to picture it.
Yeah, because you don't need a massive, philosophical, large language model if all you want to do is digitize some paperwork. Take Amazon Textract, for example.
Textract is fascinating because it tackles a wildly unglamorous but incredibly expensive business problem: unstructured documents.
Right. If a hospital gets a faxed patient intake form that has terrible handwriting, checkboxes, weirdly formatted tables, they used to pay a human to sit there and type it into a database.
Which takes forever and is prone to errors.
Exactly. Textract automatically ingests that scanned document and pulls out the text, the tables, the handwriting, and turns it all into structured data instantly.
And then you have Amazon Comprehend, which uses natural language processing to analyze text. It doesn't just read the words, it understands the sentiment.
Like reading between the lines.
Yeah. Is this customer support email angry or happy? It can extract key entities, like flagging every time a specific competitor is mentioned across 1 million social media posts.
And if you need visual data processed, there's Amazon Recognition. It analyzes images and video feeds. It can do facial analysis, object detection, or automatically moderate content that users are uploading to your platform.
Plus, we have to mention Amazon Q.
Oh yeah, Q's a big deal.
It is essentially an AI-powered assistant for the developers and business users themselves. It can generate code, help debug software, or even look at your AWS setup and suggest ways to optimize your architecture. It's like having a senior engineer sitting on your shoulder.
So you have all these distinct tools. Textract reads, Comprehend understands, Recognition sees, Q codes. But I imagine the real magic isn't just using these tools in silos.
Not at all.
It's snapping them together like Legos.
That is the ultimate goal. You no longer need a PhD in machine learning to build an incredibly sophisticated end-to-end automated workflow.
Okay, wait, let me see if I can picture this. Let's say I run a large corporate law firm.
Okay, a law firm.
I could build a system where when a massive PDF of a spanned legal contract comes in via email, Amazon Textract automatically grabs it, reads the messy image, and turns it into clean text.
Yep, step one.
Then it automatically hands that text over to Amazon Comprehend, which scans it to pull out the names of all the legal parties and highlights any high-risk clauses. Then that flagged text is sent to Claude inside Amazon Bedrock, which writes a one-page executive summary of the risks. And finally, Amazon Q pings the lead lawyer on Slack with this summary.
That is a perfect example. And 10 years ago, building that exact pipeline would have taken a team of engineers a year and millions of dollars.
And now?
Today, an IT team can string those managed services together in a matter of days.
It's an automated assembly line of intelligence, which is
Yeah.
mind-blowing, but also, if we're being honest, a little terrifying.
It can be, yeah.
I mean, if I have this automated pipeline making decisions, reading contracts, and summarizing medical data without a human in the loop, how do you stop it from breaking?
Right, the governance question.
Yeah, how do you keep the AI from hallucinating a legal clause or generating completely inappropriate content?
That is the critical challenge of scale. As you move from experimenting with AI to relying on it for your core business, governance cannot be an afterthought.
Can't just hope for the best.
Exactly. You can't install the seatbelt while the car is driving down the highway. AWS tackles this by integrating security and responsible AI directly into the platform, most notably through something called Bedrock Guardrails.
Bedrock guardrails. How does that actually work in practice?
Think of it as a set of strict, customizable boundaries for your AI. An organization can define exactly what the AI is allowed to talk about, and more importantly, what it is strictly forbidden from discussing.
So it sets the rules of engagement.
Right. It filters out harmful content, prevents the model from using profanity, and restricts responses based on your specific business policies.
So if I build a customer service chatbot for my bank,
Mm-hmm.
I can use guardrails to ensure that no matter how hard a customer tries to trick it, the AI will never give out stock trading advice because that violates my company policy.
Exactly. It keeps the AI on script. Combine that with standard enterprise security like identity and access management, which ensures only authorized employees can even access the models, and you create a highly controlled environment.
It mitigates the brand risk of an AI going rogue.
Exactly. You don't end up on the front page of the news for a chatbot malfunction.
Okay, so we have the kitchen to build models, we have the restaurant to order pre-trained models, we have the specialized interns, and we have the guardrails to keep them all in check.
The whole ecosystem.
Right. But where does this all lead? Because looking at the trajectory of all these tools, it feels like we are on the verge of a much bigger shift. There is a concept that keeps popping up in the sources right now. The move toward multimodal AI agents, and autonomous workflows.
Yes, that is the frontier.
Are we already seeing the end of the chatbot era?
We absolutely are. I mean, the chatbot era where AI is primarily a conversational partner that just answers questions is really just phase one.
Just scratching the surface.
Exactly. The shift toward AI agents is the transition from AI that talks to AI that acts.
What's the difference in a practical sense?
Well, a chatbot can draft an email for you if you ask it to. An autonomous AI agent is given a broader goal.
Okay, like what?
It will monitor your inbox, realize a client is asking for a project update, automatically query your internal database to check the project status, draft the email, review it against company policy, check the client's time zone, and send the email at 8:00 a.m. their time,
Wow.
all entirely on its own without you ever prompting it.
It executes multi-step workflows. But hold on, if you have a company running thousands of these autonomous agents, constantly thinking, constantly querying databases 24/7, the sheer amount of computing power required to sustain that must be astronomical,
Oh, it is.
far beyond just pinging a chatbot once a day.
You've hit on the exact reason AWS is making a massive pivot in their hardware strategy right now.
Oh, really?
Yeah. To support fleets of autonomous agents, relying on standard GPUs from companies like NVIDIA is becoming cost prohibitive. The math simply doesn't work for mass enterprise adoption.
It's just too expensive.
Way too expensive. So AWS is designing and building their own custom silicon from the ground up.
Wait, they are making their own chips.
Yes. Specifically, chips called AWS Trainium and Inferentia.
Okay, break those down for me.
Well, Trainium is designed specifically for the heavy lifting of training new foundation models, but Inferentia is the really crucial one for this future you're describing.
Why is that one crucial?
Inferentia is built for inference, which is the act of actually running the model once it's built. By building custom chips optimized purely for inference, AWS is trying to drive the cost of computing down so low that running thousands of autonomous agents becomes economically feasible for everyday businesses.
So they are completely vertically integrated the power grid. They own the servers, they own the software, and now they are inventing the actual copper wire to make it cheaper.
That is exactly what they are doing.
Okay, let's bring this all together for you, the listener. If you are managing IT for a mid-sized company right now, you are probably sweating looking at your cloud bills and wondering how you survive the AI transition.
It's a stressful time.
Or maybe you're just incredibly curious about how the digital world is being rewired. The massive takeaway here is that the barrier to entry has fundamentally changed. You do not need to hire a dozen highly specialized data scientists to configure networking cables.
No, you really don't.
You just need a clearly defined business problem, your own secure data, and the willingness to let managed services do the heavy lifting.
It is the ultimate democratization of enterprise AI. I mean, the kind of raw computing power and intelligence that was exclusively available to multi-trillion-dollar tech giants just 3 years ago is now available to a local logistics firm via a simple API call.
It's an entirely new playing field, but
Yeah.
thinking about where this is heading, especially with custom chips and fleets of autonomous AI agents, where does this ultimately take the concept of a business?
Well, it leads to a rather profound thought experiment, if you think about it.
Okay, lay it on me.
If AWS is successfully providing the world-class foundation models, the strict security guardrails to ensure they behave, and the cheap custom silicon to let them run constantly, we are approaching a very strange horizon. Imagine a future where a Fortune 500 level company is just a single human strategist.
A single person.
One person, sitting at a desk overseeing an AWS dashboard, while a fleet of thousands of autonomous AI agents negotiate contracts, execute marketing campaigns, and compete in real time with other companies' AI agents, all entirely in the cloud.
A company of one, powered by a grid of thousands. That is wild to think about. It really brings us right back to the beginning, doesn't it? The power plant has already been built. The high voltage lines are drawn. All you have to do now is figure out what you want to plug in. Well, thank you for joining us on this deep dive. Keep questioning how the world is being rebuilt behind the scenes, and we will catch you next time.